Hello, everyone. Happy Wednesday. It's great to talk to you all. I was going to say see you all, but at least I'm talking to you. Hope you all have had a great couple of days this week. Hope the graphing review made sense yesterday because we're going to kind of expand upon that today and do some new stuff. All right, so we're doing these things today called linear inequalities. Okay, so yesterday you graphed linear equations. Remember we talked about inequalities earlier this year. Those are ones that have less than, greater than symbols, less or equal to, or greater than equal to symbols. So we're going to look at today how we graph those if they're a linear inequality. Okay, so something I want you to write down in your notebook first. So if you need to, pause this video, go get your notebook, get something to write with. We're going to do some things like that together. Okay, a linear inequality describes a region of the coordinate plane that has a boundary line. Okay, we're going to look at what that means in a second. Okay, and then the solutions to an inequality are all the coordinates that make that inequality true. As a reminder, okay, an inequality more than likely has an infinite number of solutions. Okay, unless it has no solution, it's going to have an infinite number of solutions. That's a big difference between an inequality and an equation. Okay, so let's look at an example here. So here's one that this is a linear inequality. So y is less than 2x minus 3. So we want to see which of the following ordered pairs here will make that inequality true. So just like before, if we were checking the solution to an equation, we would plug that ordered pair in for x and y. We're going to do the exact same thing here. Okay, as a reminder, every ordered pair is always x comma y. Okay, so this first one here, this point has an x value of -1 and a y value of -7. So I'm plug those values into my inequality. Okay, so we're going to say, does -7, is that less than 2 times x, 2 times -1, minus 3? So let's simplify. So we have -7 is less than 2 times -1 is -2 minus 3. Okay, -2 minus 3 is -5. Okay, so is -7 less than -5? It is. Yes, it is. So since that statement is true, we say yes, this is a solution to that inequality. Okay, let's do the same thing with -3. Again, this has an x value of 0 and a y value of -3. So I want to see, is -3 less than 2 times 0 minus 3? Well, 2 times 0 is 0. So I want to see, is -3 less than -3? So here's the thing. If this were an equation, this would be true because we would have had an equal sign between here, and -3 does equal -3. If this was a type of inequality that said y is less than or equal to 2x minus 3, this would be a solution. But since it's just less than, -3 is not less than -3. So therefore, no, this is not a solution. Okay. So next what I want to look at is how we're going to graph. Oh, I meant these to be covered. A linear inequality. Okay. So again, this is one of the most important things for you guys to write down today. This would be a good reference for you as you go and do your practice later on. So again, I'll go through it all. I'll pause and give you a chance to also pause the video and write this down. So graphing a linear inequality is very similar to graphing an equation. Okay, you think about when you graphed equations yesterday. We looked at equations in slope-intercept form. We would plot the y-intercept first, and then use our slope to find additional points on our line. There is one difference now between graphing an inequality and an equation, and that depends on what type of inequality symbol that we have. Okay, so let's take this first one. Let's say y is greater than and not equal to the rest of the equation. For example, if I had y is greater than 3x minus 4. Okay, we're going to shade above the line. And exactly what that means, we'll look in a second, but that means every point above that line is a solution to that inequality. Meaning if I was to take one of those ordered pairs and plug it in like we did here, okay, it would be a solution. So for example, in this one, if I was to graph this, I would shade below this inequality because we saw that, okay, the point below it, -1, -7, was a solution. Okay, if it's greater than and equal to, now we still shade above the line, but the big difference here is what type of line we use. You notice this has dashed. and solid, okay? So the reason we change the type of line is it tells us if points on that line are solutions or not. So if it's greater than not equal to, that means that points on the line are not solutions, and we show that by using a dashed line. Guys, think back to when we did this in chapter 3. Okay, we would graph on a number line. Remember we sometimes use a closed circle and an open circle? That's the same thing that's happening here. Okay, so if I was to graph, let's say, for example, I'm going to write one down the side here. X is greater than 3. I would use a open circle and then graph to the right of that line. It's the same idea here because we were showing that 3 itself was not actually a solution. Okay, same thing here. We're showing that points on the line are not actually solutions to that inequality. Okay, next, if y is less than not equal to, we're going to shade below that line. But again, it's not equal to, so we're going to dash that line. And then if it's less than or equal to, we'll shade below the line and we use a solid line. Okay, so take a second and please jot this in your notebook. Okay, if you're all set, we're going to move on and look at a couple examples. So here's 2 already done out. So the first one says y is greater than or equal to 1/2 x plus 1. So first, pretend it was an equation. It said y is equal to 1/2 x plus 1. Think of it as if it was in slope-intercept form. Okay, I would plot the y-intercept of +1, right? That's our b value. So I'd put a point at +1. Then my slope is 1/2. So from that point, we'd go up 1 over 2. Up 1 over 2. So that is the same as when we graph equations. Now, we have to decide 2 things. First of all, do we use a solid or a dashed line? And then do we shade above or below this line? So if you look at the inequality here, it was y is greater than or equal to. Since it's or equal to, that's what causes us to draw a solid line. I used to hear Mr. Colangelo say this, but if you see a line, draw a line. That was his little catchphrase. So I see a line and my inequality symbol, so I'm going to draw a solid line for my graph. And then we got to decide which way to shade. So it's y is greater than or equal to 1/2 x plus 1. So when we say above the line, the best way I found is that if you focus on where the line crosses the y-axis, okay, we want to shade the y values that are greater than this line. So that's what we say shade above it, meaning shade above the values in the y-axis when it comes to shading. So I shaded up here. The next one, y is less than -2x plus 2. Okay, again, I started just like it was in slope-intercept form. So I put a point on its y-intercept. Okay, slope of -2, so I go down 2 to the right 1, down 2 to the right 1. And now we have to decide 2 things, solid or dashed line, and then shade above or shade below. So again, it's y is just less than, not equal to. So that's why we pick a dashed line. And then since y is less than, I focus on where it crosses the y-axis, and we shaded below that line. Okay? So I want to show you guys 2 things really quickly with these 2 examples. Okay? I want to show you why we use a solid dashed line again. Okay? So if I took a point, let's go back to the example on the left. Let's take a point on this line. Let's say I take 2, 2. So you know what? I'm going to go 4, 3. So I'm going to check the point 4, 3. Okay, and let's plug that into my equation. So if I checked, is 3, the y value, greater than or equal to 1/2 x, and x is 4. Let's write that. So 1/2 times 4 plus 1. Well, 1/2 times 4 is 2. 2 plus 1 is 3. So is 3 greater than or equal to 3? Yes, it is. That means that points on this line are solutions, and that's why we draw a solid line. Think of the same thing over here to the right. If I picked a point on the line to the right here, I'm going to go with the point -1, 4, this point right here. Okay, and plug that into my inequality. And see, does 4, or is 4, less than -2 times -1 plus 2. Well, -2 times -1 is 2. 2 plus 2 is 4. Is 4 greater than 4? It's not. Or sorry, is 4 less than 4? No, it's not. So that point is not a solution. Again, that's why we draw a dashed line like that. Okay? Then another thing, if you really wanted to check what you could do, right now, I want you to pick any point in this shaded region, any point at all, and plug the x and the y value into this inequality, and it will make that inequality true. For example, I'm going to pick one at random, -3, 2. Okay, we'll plug that into my inequality. The point -3. Okay, let's check. Is 2 less than -2 times -3 plus 2? Well, -2 times -3 is +6. 6 plus 2 is 8. Is 2 less than 8? Yes, it is. Right? That point is a solution. And guys, that's why we have to shade, to show that there are a lot of points that could make that inequality true. Okay, let's do some more examples. So let's graph this one. So y is greater than 2/3 x minus 1. Again, we're going to start by pretend like it's in slope-intercept form. So I'm going to plot its y-intercept. So its b value is -1. So it crosses the y-axis at the point 0, -1. Slope is 2/3. So I'm going to go up 2. Show my mouse up 2, to the right 3. 1, 2, 3. Put a point. Up 2, over 3. 1, 2, 3. Put a point. Now we decide if we use a solid line or a dashed line. Since y is greater than and not equal to, we're going to use a dashed line. Okay, so I'm going to go in here. I'm going to cheat a little bit, and I'm going to put it in my dashed line. Okay. You know what? Let's make it blue. And to make it totally accurate, we should put arrows on both sides of that as well. Arrows, because that line goes on forever. Now I decide which way we shade. So y is greater than. So look at where my line crosses the y-axis. We want to shade above the line from there. So you could shade it one, two ways, guys. If you have highlighters, it would look really nice if you go and highlight and show that every point above that line is the solution. So I could go to my highlighter. Uh-oh. There we go. And I could highlight above that line, really go into detail, because now every point in this region would be a solution to that equation, or to that inequality. But if you don't have a highlighter, what you could do as well, and this is something I do if I don't have a highlighter handy, is just take your pencil and you do a light shading, or you can even just do this and draw some lines, nice and light. It's going pretty slow. Come on. All right, let's try this again. Let's see. Pen. All right, and just draw some lines like this. Just to show me that you are recognizing that region as containing the solutions to this inequality. Okay, let's do another one. So let's look at the inequality. Okay, y is less than 2x minus 5. Again, in slope-intercept form, so its y-intercept is the point 0, -5. So we'll go down to the y-axis. 1, 2, 3, 4, 5. Put a point there. Slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. Okay, now I decide what type of line to use. Since y is less than and not equal to, we're going to use a dashed line. Okay, again, make it accurate, so put arrows on both sides. And then we got to do shade above or below line. But y is less than, So look at where y crosses the y-axis. It's crossing down here. So I want to shade below that line. So we're going to shade down this way. Okay, that's the region below our line. Next one, y is greater than or equal to negative x. Again, it's not written here, but its y-intercept is 0. So it's crossed at the origin. Slope is -1, so I go down 1 over 1, down 1 over 1, down 1 over 1. All right, y is greater than or equal to. So since it is or equal to, we're going to use a solid line. Okay, let's use a solid line. I'm going to extend this out a little bit. Okay, let's put arrows on both sides. Oh my goodness. All right, well, it's not working. And then greater than, which means we shade above. So I'm going to shade above my line. All right, get out here, video. Whew. All right, have some technical difficulties today. So go ahead and try these two on your own. Okay, go ahead and I know a lot of you probably don't have graph paper. Okay, and we kind of expected that. So instead, in your notebook, just do your best to draw as neat as you can an x-axis and a y-axis, and graph it to the best of your ability. Okay, that's all we're asking, is try your best. All right, so let's go ahead and go over it really quickly. So my first one, y is less than 3x minus 6. So we're going to show across the y-axis at -6. So 1, 2, 3, 4, 5, 6 way at the bottom here. Okay, slope of 3. So we went up 3, 1, 2, 3 over 1. Up 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, looks like it's not equal to. So we're going to use a dashed line. Okay, and y is less than, so we want to shade below that line. So it's crossing the y-axis down here. So I want to shade below that, which would be this way. Okay, next one, y is greater than or equal to -1/4 x plus 1. So it's y-intercept is +1. So we're going to show it crosses here. Slope of -1/4. So we're going to go down 1 over 4, down 1, 1, 2, 3, 4. I'm kind of out of room. So instead I'm going to go up 1 and to the left 1, 2, 3, 4. Okay, so y is greater than or equal to. So since it could be equal to, we're going to use a solid line. Okay, let's put arrows on both sides. Like I should have done for the first one too. And y is greater than or equal to, which means we're going to shade above our line. So this region over here. All right, so that's it for graphing. The other thing I want to do too really quickly is just go backwards. So let's say we had the graph. Let's write the linear inequality for this. Okay, so we first want to kind of take this example. Let's identify its y-intercept, its slope, and then figure out what inequality symbol we're going to use. So it looks like this one crosses the y-axis at +4. Okay, and if I look at other points on my line, I got one down here, one down here. Going from left to right, okay, we're going up 1, 2, 3, 4 to the right 1. Up 1, 2, 3, 4 to the right 1. So our slope is +4. So we have a slope of 4 and a y-intercept of 4. Okay, so I'm going to say y, again, not equal to. Let's think about what inequality symbol I should use here. I see a dashed line, okay, and our shading goes below where our line crosses the y-axis. So we're going to say y is just less than. Again, we're going below the line, so it's less than. Dash line means not equal to. So y is less than, and then use our slope and our y-intercept. So 4x plus 4. That's it. Okay, you try this one on your own. Come up with the inequality or for this graph. All right, let's go over this one. So I'm looking at, let's get some points on here first. Cross is here, here, there, there. Okay, so it looks like its slope is -1, so it's going down 1 over 1. Its y-intercept is +1. Okay, so y, let's think about the inequality symbol. So I see a solid line, and we're shading above where the line crosses the y-axis. So it's going to be y is greater than or equal to. Again, greater than because we're shading above the line, or equal to because we have a solid line drawn. And then use the other information, so -1x or just -x plus 1. All right, guys, so here's what we want to do now. So our next slide contains, we're going to have 4 questions for our lesson check, okay? Here's the first 2. So what I want you guys to do is pause this video, okay? Write down these examples, do them out, and then I'll go to the next slide. Okay, now if you're ready and you got these down in your notebook, okay, you can continue on. Here are the next 2 examples for your lesson check. Okay, this is going the opposite way. So here is the graph, write the inequality. Again, pause this video, just know that the yellow region, that's representing the shaded region of these graphs, okay? All right, once you finish those 4 examples, what you're going to do now is in your notebook where you have those 4 examples done, we want you to take a picture, okay, and upload the picture of your work. 2 options. Either there's a Google form on P-Learning you could upload it to, or you could just email it to your teacher, okay? And the last thing for today, guys, is the GIF that you didn't know you needed to see today. It is a bulldog jet skiing. And with that, have a great rest of your day.